Welcome back to Incremental, the continuous improvement podcast, our concepts edition for the week. I am Devin Bedoni.
And I am Uriel Eisen.
And we're going to be talking a little bit more, some high-level thinking about push, pull, flow. I think I've had some realizations about it this week. And then Uriel has some interesting things to go in about
We're diving into a very bad day of production as we're looking at some very large orders. And so just the learning from that.
And some stuff about automation and kind of like markers maybe, or like benchmark points you need to get to, and like failings that aren't super obvious off the bat. Potentially.
I think so. Yep. So that's what we'll be talking about. Quote for the day is know-how alone isn't enough. You need know-why, from Shigeo Shingo. And the idea there, which I thought was kind of clever, people talk about know-how.
Yeah.
It's sort of twofold. One is that without know-why, like knowing why something works or why it isn't working, that is what allows you to extrapolate it to other things and implement it on diverse, in diverse applications. And secondly, a lot of these things around like SOPs, making things visual is about getting information out of people's heads. Yeah. And so know why is kind of like, you don't want a buildup of know-how. You kind of like, it means you haven't really learned from anything. It's
sure. Yeah.
It's just, the steps to take, which I guess is a start, but
the way I read it as well is that like, know how, like, you can't improve something that you don't know how it functions,
or like why it's working the way it is.
You need to know why it's working in order to improve it, because otherwise if you're trying to improve something that you just know how to do but you don't know why it works, right, you're just sort of stabbing in the dark.
And actually I pulled that out of a chapter from Key Strategies for Plant Improvement by Shigeo Shingo, and in it he gave a lot of examples of problems that people were having in their factories and couldn't solve and had sort of tried to solve, and he solved, and I have a point about this later so we can sort of dive into it further, but he solved it by sort of really breaking down like all of the things that were happening. Like one of them was a foaming bath of, I forget what they were doing in the bath, but it was foaming. And the foam
scrubbing themselves.
Oh yeah, it was just a bubble bath. And it was spilling chemicals on the floor, so they were losing chemicals and also making a mess. Yeah. And it was costing them a lot of money. And so he was like, well, what is a bubble? It consists of a film and it also consists of air. So we can either disrupt the film or try to remove the air. And it was like, interesting. Yeah. Like to really just dig into exactly what is happening.
Yeah.
Or like another one was about like convection versus conduction versus radiated heat, and just understanding that all three of those things are working. And that was in like a tea drying facility. And that sort of allowed him to come up with a good solution.
Yeah. One thing that is cool about the Shigeo books is it's like not just car production, which I feel like, like
totally
the Toyota way goes into other case studies, but is really focused on Toyota.
Yeah.
And kind of what they do. And yeah, Shigeo, has all these case studies from like washing machine manufacturers or a tea drying facility. And
right.
Like all sorts of stuff.
Yeah, it's pretty cool. Actually, the one I wanted to show you is an example from a stamping shop where their issue was that they do too many different parts because they're essentially a job shop.
Yeah. And
he basically came back to them with like, what are the four operations a press actually does?
Yeah.
And it was like punching and bending. And I'm not going to remember all four, but it was kind of like under it all, which I think is what you kind of came to.
I'm trying to. Yeah.
Right. It's like, oh, we don't actually do such unique processes. They just result in unique shapes.
Yeah.
There's a guy, Alexander Slocum, who is I think he's a professor at MIT. He's sort of big in the like high precision design world, and his philosophy on engineering, which sort of gets back to this quote, is that to be a good mechanical engineer, you need to know all of the math. Not because you're going to actually use it in doing design very frequently, but it tells you about the behavior of the physical world so
Yeah.
that you can design things that are fundamentally sound.
You need to understand conceptually what it represents, basically.
Yeah, like, we've talked about this one, but like rotational inertia versus stiffness on like a ball screw. If you want a machine to move faster, but you don't want ball screw whip, you could say, oh, well, let's go to a larger diameter ball screw. And so stiffness, and I might get this slightly wrong, but like stiffness increases to the third power with diameter, and rotational inertia to the fifth power. And so you can immediately see that you're going to have
an issue.
an issue.
Yeah.
Anyway, yeah. So it's good to have a deep understanding of things.
Yeah. Maybe jumping off there. So we implemented our new job system this last week. And I think, last episode we were just talking about it. So we did a first pass, and it's already really cool. Okay. And it's already highlighted a lot of issues.
Excellent.
So it's doing its job. And it kind of made me, like, in attempting to implement it and sort of define the different quote unquote Kanban bins, I had some interesting realizations just about like kind of push, pull, and flow. And I had this analogy for a way to like visualize the difference between pull and flow.
Okay.
And if you think of like a bunch of kids in a playground, like when they're going up steps, that's kind of like pull. Like a kid climbs a step, the step opens, and then there's room for the next kid to take a step behind them. And then when they get to the top and they go down a slide, that's kind of like flow. Like things are just like carried through the process. And I was kind of visualizing a shop as like basically just like a bunch of stairways and slides. And then you get another queue at the bottom of the next stairway. And then,
interesting.
Not that it's like revolutionary or unique, but I was, staring at this board thinking about kind of the way things move through our shop.
Yeah.
And it just can be really hard to actually visualize what's happening and like what sort of state your different systems, different operations in your process are.
Totally.
And in the like drive to create flow, I think sometimes we conflate things that are pull or maybe even push with flow, because we're like, oh yeah, that moves pretty smooth.
Right.
When it's not actually. And one thing that I kind of came across was I was writing these like columns on this whiteboard. And I found myself using different language for like intuitively, but then I was trying to like lay out this full Kanban system that was all pull. And then I was looking at the board and I was like, oh, I changed from past tense to present tense, like at this one spot in the board.
Interesting.
And so I think language can be really telling. And so I was continuing to try and use this like kind of Kanban pull functionality. Yeah. And I was like, why is it not working right here? Like, what is wrong? And then all of a sudden I was like, oh, from this point forward, things kind of flow, or in the sense that we don't really have cues. So
I see.
I switched to like present tense at that point. And
interesting.
It kind of also happens to be like where our main value add is and sort of our bottleneck. Like I don't think
around the machines.
Yeah.
And then after that, it just moves from one to the next.
Yeah, it essentially does. Like we, might have small cues here and there, but they're not not necessary.
They're due to your real bottleneck, which is human labor.
Yeah, or they're just due to how we're doing it right now, because they're not actually, those cues aren't a constraint in any way.
Right, so it's not urgent because there's nothing really waiting.
Yeah.
And if two build up in a queue, you can easily tackle two instead of one.
Yeah, exactly.
Gotcha.
So I thought that was really interesting, just as a kind of an analysis tool to like think through your processes and consider whether you intuitively put them in the past tense or the present tense. So essentially I was like organizing things by if they were done.
Okay.
And that indicates to me that that's like sort of a batch and pull process. When their status in your mind is like, this is now complete, it is ready for the next thing.
Yeah.
That indicates to me at least in our process.
Definitely.
That is something that we wait for to be pulled from for the next process, and things upstream are waiting for it, essentially.
Right, and it definitely indicates a batch.
Yes.
Right, because, well, I guess you could wait for a really long cycle time.
It can be a batch of one, but it's still like pull.
Right.
And there is delays, I guess, would maybe be the more key feature, whether it's a batch of one or a batch of many, that there's upstream processes waiting for it.
Sorry, is that upstream or downstream?
Sorry, downstream.
Okay.
Yes.
Doesn't really matter, but it is good to...
Yeah. And then as soon as I found, basically I went from whether something was complete as being the kind of indicating status to whether it was running as being the indicating status in my head.
Okay.
And that was kind of like the transition point.
Sorry, I'm not quite following that last piece.
So when I was writing these columns on the board, I intuitively wrote the first bunch in the past tense, as in this has been done. It is ready to be pulled to the next.
Okay.
And then there was a certain point where I intuitively switched to saying this is in process.
Gotcha.
This is being done.
This is being done, or this is sort of on that station and at any point someone can walk over and do it?
Yeah, same thing.
Okay.
In my head.
Gotcha.
Yeah.
Interesting.
But sort of, present tense versus past tense.
Interesting.
Yeah.
Any other...
Yeah, they're a little more nitty gritty into the specifics, but they, in the Toyota way, there's a lot of discussion about how if you just transition to lean or single piece flow right away, you'll have crazy delays.
I have a great example of that.
Yeah. Well,
Yeah.
I foresaw it, I think, thankfully.
Okay.
But I had this whole awesome vision where we're going to be ordering the stock just in time because this, all the processes will trigger and we'll have a week-long queue in total for each workstation. And then I looked at it and I was like, oh, well, I'm incredibly behind on programming. That means that all of these other processes haven't been triggered forward. So there's this big delay in the middle of the process, but I'm capable under pressure of moving a process from nothing essentially to running in a very short amount of time. Mm-hmm. But if the stock's not here, we can't do that.
Yes.
So it made me realize that we're going to have to, I think, sort of keep the upstream processes full prior to being triggered, maybe.
Okay.
Until we get caught up and sort of like build up the necessary buffer inventory in the processes up to the or through the bottleneck, essentially.
And the bottleneck, as you said it there, is referring to the machines?
No, the bottleneck there is really, from a labor standpoint, is really pretty clearly programming at this point. Yeah.
Okay.
I don't think it's necessarily programming. I think it's programming because I do the programming and I also run the business.
I was going to say, just zooming out and sort of highlighting maybe some success, because I feel like when you're in it, it's hard to see.
Yeah.
I remember having these conversations when the bottleneck was more things because you hadn't handed off doing setups on the machine.
Uh-huh.
Right. And so you always had to be the one doing every setup.
Yeah.
And so now you've successfully sort of handed off that, but also like come up with a lot of improvements around how that handoff happens.
Yeah.
And now that that's not an issue, it's a new issue.
Yeah. Which is, furthering a lot of thought about how and where we add labor to the business, which I'm still pretty undecided on. Mm-hmm. Where was I going with that? Oh, anyway, just that when you transition to this kind of more just-in-time process, you really do need to make sure that you have enough buffer inventory.
Right.
And another kind of like highlighted thing was just like making a running change like this is definitely challenging. Like a running change from one system to the next.
When you say running, like how you're running or while you're running?
While you're running.
Okay. Yeah. Yeah.
Yeah. And we had this moment where we were kind of like staring at the board all together, trying to comprehend like how we were going to handle this like stock ordering bit.
Mm-hmm.
And like the way I had initially organized it didn't make a lot of sense.
Okay.
And it's amazing how something fundamentally so simple can really be quite complicated. And then most of it came down just to the fact that like, because we were doing a running change, we didn't really know the status of the quote unquote bins. Right. Like there was work in progress. There was some stock ordered. There needed, but we were just kind of like, what is this? Is this full or is this empty?
Yeah. Interesting. And I think just, like for listeners, I guess what makes ordering stock challenging is not the ordering of the stock. It's that if you order anything that lands in your inbox that says like, hey, can you make these parts for us? And then you say, sure. And you agree on a price and they give you a PO. If you immediately order the stock for that job, you run into the problem of you have a huge amount of cash tied up in aluminum that you might not run for another 2 months or something, or 1 month or whatever it is. Yeah. Right. So then it's sort of like trying to order it just in time, but not too late. And it's probably better to order it too early. I mean, it's definitely better, except that if you always do it too early, you never will figure out what's going wrong, right? You want to keep dialing it back. And that's sort of that idea of lowering your Kanban quantities till you have an issue. Yeah. So you figure out what went wrong.
And that's what we did when we were reorganizing that part of the board, is we changed the value as well. So initially I had been like, I want to have
like the trigger points.
Yeah. Okay. I wanted to have like a day and a half's machine run time of stock in the one bin and a day and a half's worth of stock in the other bin. Okay. And then as well as like the buffers and the downstream processes until we got to run. So the total equaled like a week rather. Okay.
And that's the lead time for materials arriving.
Yeah. But then we readjusted it. So there was a total of a week just in the material ordered amounts.
That makes sense.
So that, and we started by, I was remembering back to when a customer of ours started, who they managed their inventory with Kanban.
Oh, cool.
And they were like, we use this, let's say 500 units a month. Mm-hmm. So our first order is 1,000 so that we can fill both bins. Okay. And I was like, oh yeah, we just haven't done that yet for an internal process. So I was like, I had been holding off on ordering all this stock. And I was like, oh, just order it all. We need both of the bins full to start this process because they feed all the other processes. And we'll never have like a reliable trigger point unless we sort of start from zero.
Everything's triggered all together. It's not that useful.
No, it's very challenging.
It sort of loses its value of giving you information in the order it's needed to be executed on. Yeah. Which is something we've been struggling with, where our quantities are not right. Our Kanban quantities are not right. So when some Kanbans trigger, if you don't address it like right now, we're going to have a problem. And other ones, it's like, so, it will be like 3 weeks before we have a problem. So like all of our painted stock that's ready for assembly right now, for no good reason, there's one reason, but it's not a good reason. They're all the same levels, even though there's some colors that are way more popular than others. Yeah. And the best example is the orange cam, which goes in a few very popular color combos. Mm-hmm. And so if that gets triggered and we don't run it like the next day, there's a very good chance we'll just run out, which means we end up shuffling our Kanbans to put that at the front of the queue, which is antithetical to the premise, right? Yeah. We should reduce all the other ones. Like, just because they're the same product type, I think is obscuring the fact. Like, we should just treat them as totally separate items.
So for the sake of like more high level thinking, what has been the constraint that's kept you from adjusting that?
What you were just saying about making it like running changes, like changing while going. Yeah. I think it's that, coupled with the fact that it's not hurting our business. So you were sort of saying like it's hard as a business cash flow wise to have tens of thousands of dollars sitting in stock.
Yeah.
This isn't tens of thousands of dollars, right? So it's not actually a constraint on the business, but it is inefficient. It's a bad idea. It's poorly. It's just not urgent.
It's basically a constraint on your labor, though. It sounds like it is like an operational.
It's inefficient. Yeah. Yes, it absolutely needs to get resolved, but it's not like.
I guess what I'm wondering is, like, from an outside standpoint.
Yeah.
Not knowing all the details. Mm-hmm. You know, if I were listening to this, I'd be like, why doesn't he just change the numbers? But obviously there are other issues. So what are those other issues?
Oh, that's a good point. So we actually just did that the other day where one re-triggered and we were like, let's just change the number. So the other issues, they're not issues. It's like you've been doing something one way and you know it works and you don't necessarily want to take the time to think through all of the implications of making a change. So I'll just list out some of the other things. That's not to say that they're real problems. So one example is historically we've always done 4 batches of sort of in our oven. We have 16 racks. Yeah. So we'll do 4 racks of one color, 4 racks of another color, 4 racks of color 3, 4 racks of color 4, and 4 racks represents the Kanban quantity we have at the assembly station. Now, you can obviously very easily just say, okay, well, let's do 2 racks and reduce that quantity to 16. The racks of 8, so that would be 16 parts, right? So that's what we did. The other piece is right now we have a high inefficiency of doing a color change. It adds a lot of time. And, you know, that would indicate that we should work on reducing the time to do a color change, but we haven't managed to make a serious dent in that. Yeah. So it's one of those. It's like, I don't know. Yeah.
So, I mean, obviously the goal is to reduce inventories, but could you also just increase the quantity of the one that has a higher demand?
Very, very innovative thinking there. Yes.
Because it seems like the running change of just double batching the high demand product. Yeah. Yeah. And not reducing the others. If more or less the system works. Seems true. Like a simple way to go. And it just kind of falls in the classic like mixed model production of like A, B, B, A, B, B, A, B, B. Which you're probably ending up doing anyway, just sort of like urgently instead of predictably.
Yes. I feel like this is a good example of like, I know better, but I'm not doing it, which is, I am very convinced that reducing it is the right move because we shouldn't have so much machine time and human time tied up in parts that we're not shipping. Not because there's some ideal of minimal inventories, like for the very real reason of when we receive, like we're working on some much bigger quotes now than we have in the past on just much larger volumes. Yeah. And they're really going to push our total capacity to produce.
Yeah. You mean they're going to challenge your total capacity?
Like,
right?
We're going to have demand that exceeds our ability to make buckles per week. Yeah. And so we're going to account for that in our quoting, but it is obvious that if we could increase our throughput, we could increase our revenue and profit linearly, you know? Right? So like, but then if we get one of those triggers in the midst of that, that triggers production on stock that we're really realistically not going to sell through for the next 4 weeks. Yeah. That's like bad. Yeah. And it's because I am looking at it from a station perspective of I don't want to take an extra 3 minutes or 5 minutes to do a color change. But yeah, 5 minutes.
I get you.
Yeah. Yeah. No, it's
I mean, I think it's fun to have this forum, as it were, to like talk through what we should be doing. Yeah. Because it's so, in your head on the daily, it's really easy to think about all these things, but then it's just in your head and you're like, well, can't tackle that today.
Right.
we had our first, actually, when was it? Maybe it was just during our one of our discussions about how we're going to organize this job board.
Mm-hmm.
Ariel was like, I finally am starting to see the stuff you've been talking about for the last year and a half. Like this stuff is coming together. And I was like, thank you. And my God, this has taken a long time.
Yeah.
You know, because it's just these little, for the most part, these little bite-sized pieces, and then sometimes a big rollout of a system. But yeah, it's like we have been sort of driving in this direction for a long time now, and we're like, it feels like some of these things are just starting to come into practice.
Yeah.
And then there's the little niggling details of, like, you know, changing the quantity from 32 to 16 or whatever. And
right.
You're just like, well, there's this other thing that I have to do tomorrow.
Yeah. And to be like, not to let ourselves off the hook, but
Yeah.
also to be fair to ourselves, I guess. Reading about Toyota and about these other companies, Herman Miller or whatever, who have successfully implemented this, that is a huge organization.
Yeah.
Which makes it more impressive in a lot of ways, right? Mm-hmm. That they were able to make that transition. But also, it's worth bearing in mind that they have departments that are dedicated to each business function. And so I think one problem I run into is that more effort from me going into a particular area of the business almost by definition means neglecting or a reduction of effort going into a different part of, another part of the business. And so like for me, and I've talked about this here, but improving the product line we offer and improving the efficiency of production there is at the moment really juxtaposed to sales, which has been going fine, but really R&D, so producing new products.
Yeah.
And that is where this business is going to grow more than any other area.
Yeah.
I don't know. So I don't know how to balance that, but
yeah. It's definitely a challenge. Having this new system up the last week.
Yeah.
Was quite elucidating and, you know, clarified the holes, I guess you could say, in a way that I already knew, but now they're like stark and defined. And
that's very cool.
Yeah. Now it's like, okay, there's things to deal with. There's problems to deal with in the business, and that one's obvious now. That one being a lack of labor somewhere, you know, in this like administrative sales / R&D / programming like suite that I sort of cover.
Yeah.
And when I say R&D for us, that's mostly about like process R&D more than product R&D.
Like you're talking about work holding for a while.
Yeah, like there's all these kind of hanging projects that we need to tackle at some point.
Right.
And I struggle with the same thing of being like, I can program today, which according to that board really needs to happen.
Yeah.
I also need to do this, you know, I need to figure out what our long-term work holding strategy and 0-point system is going to be. But I guess not today because programming needs to happen.
Yeah.
And then it ends up being like every day is that.
Yeah. So a couple weeks back, we had that like sort of zooming out, overarching, you know, where's the business going kind of episode. I left that feeling like, man, I really need to nail some of those things down. Yeah. And maybe be a little less, on it in terms of doing daily improvements. But then I had this moment of I woke up from that because we have gotten here because of all those improvements. They have been so big in our business. I mean, we've increased production by 500% before growing the team. That came at a cost. Like I put in that time on that instead of releasing new products. So I'm not going to say it's 100% win, but like the revenue of that business now allows a lot of other things. So again, I'm not saying it's the only way to go, but like those, we played with those spreadsheets a little while ago. Yeah. On like the accumulation of time saved. Like compounding is
It's real.
is real. Is so real. It's
Just
like,
ask a banker.
yeah, it's so real. It's unintuitive. Like you look at that and you're like, that must be wrong. Like that was my first response when my brother made that spreadsheet and I sort of typed in some numbers and I was like, there's no way. Because it was like, I forget the exact numbers, but it was basically after 3 years, you will be 3 years ahead of where you would have been had you made none of those improvements. And I put in pretty meager numbers of like you're spending 60 minutes a day on improving and that yields whatever amount of savings per week. And it's so huge. So like, I don't know. Yeah. It's both.
It is both. I also need to like personally zoom out and remember that I'm just not focusing on work holding right now. Like I've been focusing on this like job management, data management system.
Yeah.
And that does absolutely take time away from production. And sometimes it's hard to think about that as the improvements I'm making, even though I spent probably more than 5 hours, definitely more than 5 hours this last week on that process, on that system.
Now,
so it can feel like I'm not doing anything, even though it's a lot.
Yeah. I mean, we talked about process versus operations a couple episodes back. And the consensus, I think, is focus on process improvements before operations. And I feel like work holding feels like an operation more than a process. Maybe not. Maybe the world of work holding is a process.
I think that's more what I'm trying to tackle.
Okay.
Is having, like taking work holding out of being an operation.
I see what you're saying.
And
right.
Like,
it's not like, how do I hold this type of part? It's more like, how do we hold all parts?
Yeah, exactly. Like codifying, we always tackle it A, B, or C. And so that it's not an operation that takes problem solving.
That makes sense.
In the moment.
Nice.
Yeah.
Any other, or I know you wanted to talk about some of the nitty gritty, so maybe that's next episode. Any other big picture takeaways from that job board?
Not off the top of my head.
Well, maybe I'll jump into our...
Yeah, let's do it.
Our bad day of production.
Bad day.
So I'm trying to think how this series of events unfolded. But last Wednesday, basically we've had issues breaking roughing mills, which I think I alluded to last week. Last week I was like, I think I fixed this problem. I cut a relief in the top of the jaws for this burr from the saw to sit in. Promptly broken end mill right after. We actually ran a cycle on that. So on Wednesday, the setup did not happen properly, and we ran, I'm trying to remember exactly, we ran the program for 1-inch cams, but installed the vice jaws for the 3/4 inch cams.
Oh, how'd that happen?
I wasn't there.
Your system is so dialed.
Apparently not dialed enough. So actually we have 2 parts that share one tray. This is off of that tray. So we're gonna eliminate that.
We got to visit your shop for the first time in months, I think.
Yeah.
And I left just being like, wow, this is looking good. It's dialed. But I do remember, like, you pulled that tray out, and I was like, why is there 2?
Well, should have said something. No. Anyway, so that happened. It didn't cause a crash because they're such similar parts. Just one is held, 1/4 inch higher than the other. Yeah. In op 2. And so it just was like, I walked up after it ran 30 parts out of 40-ish, and I looked in the bin of quote unquote finished parts. There was not one part in there. So I was like, this is not working well. Anyway, so that happened. In running it, while they're similar, they're not identical parts, and so it damaged the vice jaws for our 3/4 inch cams, which was a bummer. Then we were like, okay, so the 3/4 inch cams are having this issue of breaking end mills. We were waiting on more end mills to come in, and so we only had like 2 left, which, 1 is none and 2 is 1 kind of thing, but 1 is close to none. Anyway, so we didn't want to run that. So the only other part we had Kanban's calling for was our 3/4 inch body. So we were like, all right, we'll run that. Well, 2 days before, we had found, finally, and I wanted to give an update on this. We had 3D printed a lot of our gripper fingers for our automation.
Yep.
They finally gave out. So Sam was like tightening the screws down, and like they just weren't going tight.
Yeah.
And he like took them off, and they're just like full of cracks. But that was after, I don't know. I'd have to look at dates, but I guess 2 months. It was October.
That's a lot of months.
4 or 5 months.
October?
November, December. Yeah, 5 months. Right, we're in April. Shit.
We're in May.
We're in May. Okay.
Yeah.
Well,
so 6 months.
So plenty of time. So
That's
it wasn't
a lot of production.
Yeah. So I wasn't like, and interestingly, we the gripper fingers that have run, we make a lot more 3/4 inch cams than we do 1 inch cams. The 3/4 inch cams were equally cracked as the 1 inch cams, which gives me the sense that it's some sort of chemical degradation from the coolant that's just has some time element to it, and it's not about really the mechanical stresses so much.
That makes sense and is fairly predictable.
Yeah.
Or like we both sort of anticipated that.
Yep. Yeah. So anyway, not disappointed.
I'll check mine.
Yeah.
Because they've barely been used and see what they look like.
Yeah, and try tightening them up and see if they crack immediately. So I'm not disappointed in any way by the 3D printed fingers. Like, we're going to continue rolling on those. I did order some PETG to try that.
Yeah.
We'll see. I think carbon filled PETG might be nice, but honestly, it's like then we need a hardened nozzle, and it's like really highly abrasive.
Do you think it's actually it's probably not really a strength issue though? So whether it's got carbon in it or not, it's probably not that critical feature.
Yeah, probably wouldn't add to its chemical resistance. I was sort of thinking between layers if there's carbon filaments running sort of.
Was it cracking between layers?
It was cracking all over.
Yeah.
Probably a better bet is just replacing them every 3 months or on a regular interval.
Yeah.
Anyway, so we had thrown them out, and I had printed a replacement set, and then the print failed. So in that moment, we were like, wow, we cannot run any of our parts. The big takeaway, I don't know if there's one big takeaway, but one takeaway, which I've talked about months ago at this point, is that we need all supporting elements of production to be Kanban, right? Like we need a backup set of vice jaws. We should have or possibly. I'm not set on that one yet, but like gripper fingers are so easy and cheap to 3D print. We should absolutely always have a backup set sitting there. But just on down the list of like you just said, like going to single piece flow is such a, like if you just jump right in, it's going to cause massive downtime.
Yeah.
We are definitely seeing that of like we had, it was only a day, but a day is a lot of time.
It's especially a lot of time when you're making everything just in time.
Exactly. Yeah. So we are clearly not, because it didn't stop our assembly station. It didn't stop our paint department. So it didn't have all those cascading effects.
Not that day, but did it have a cascading effect a couple days down the...
It would have, but we were able to...
Catch up,
yeah.
Well, that's cool.
Yeah, but it is not cool because if we're trying to get there, or I guess it is cool to see... Like, that was the other thing, is we're quoting these much bigger jobs, and I was excited to see all these failures before we kind of had to be producing every day, or I had to make an awkward phone call to someone and be like, hey, we're behind. You know?
Also, I think it's like good to remember that like you can refine and refine and refine. Something will always happen. Yeah. So you need to have at least some buffer to account for whatever those you can't foresee everything. So there's always going to be an unforeseen something.
Yeah.
That, I mean, it comes back to like Toyota slowing down their line from what their calculated 100% capacity is.
Right. And counting on a lower number.
And counting on a lower number because they know that things are going to come up.
Right. Yeah.
So I think...
Yeah, I think there's always that. I think these are sort of low-hanging fruit in a funny way.
No, totally. I'm not saying you shouldn't do those. You absolutely should do those.
Yeah.
I think it's just good to remember for ourselves that like the goal isn't necessarily 100%. Like you always need to have a buffer for
stuff.
What is it? Murphy.
Yeah. So that was interesting. I think, Kanbans on our supporting things like gripper fingers. I do sort of feel like we should have a backup set of vice jaws. The other thing that I did in response already, so the next day I basically spent the day refining the process of making vice jaw blanks.
Yeah.
Because I kept running into this thing where like I have a new buckle, I'm not sure it's the final version, and so I wasn't making it in aluminum. I was just 3D printing it because the vice jaws were a huge pain to make, and I didn't want to like use up a set of vice jaws for something that I wasn't pretty confident about.
Yeah.
And so I just kept running into that, and I've just found over the years that like any time you're sort of hesitant to do a thing, I mean, this gets back to like reduce setup time, basically, right?
Yeah.
Like any time you're kind of like, man, I really don't want to do this, or this is a temptation to batch. So in my case, like every time I made vice jaws, I'd just make a bunch of them because it's like by the time I get the mill changed over to that setup and then make sure that the program was the right program because I hadn't run it in so long, I wasn't sure. All that stuff. So I think that will really bear some fruit in that I'll be less hesitant to just make a new set for existing products, but also, and possibly more importantly, less hesitant to make vice jaws for new products.
Yeah. I think this also like points back to, there's a lot of discussion about not attempting to roll out lean in a whole, whole business all in one go.
Yeah.
For the sake of figuring out all these little details. Totally. And luckily our businesses are very small.
Right. We are the test line.
Yeah, we're the test line. Exactly. Yeah. But I think it's a good thing to remember that like, you don't just like drop this system on a whole, larger organism and expect everything to go well. Like, and probably that we can, which we do to some extent, but take that same application into our small businesses and test it out in even smaller portions.
Yeah.
To work through some of these easier, more, somewhat more predictable failures, or just, lessons, really. They're just lessons, I guess.
Yeah. And failures, I mean, has a negative connotation in our society, but that is the goal here. Like very explicitly, the goal is to make a system and then reduce the safety factors till it breaks. Yeah. And that is the lean part, is reducing those safety factors.
Yeah.
And then when it breaks, actually chasing down that problem to the root cause.
Yeah.
I was reading The Toyota Way again, and one of the things they were talking about, which I thought, I don't know why this, we've been talking about sort of flex labor, and they were talking about how Toyota does it, which I don't know. It's not, as we've discussed, it's not necessarily how we, like an answer for us, in that like they have a lot of temp labor and stuff like that, which I don't know. It doesn't really work for me. Just logistically. Yeah. Not morally. So I thought one very interesting piece, they were sort of saying that to them, like job security was basically to them, they treat it as a requirement, right? That's a non-negotiable because they feel that offering job security, well, it's partly to do with their union and their history with their union, that they're guaranteed job work for life. I'm sure there's exceptions to that, but I think also just, and there's a lot of research for this, but like if you're asking someone to improve your business, right, every day, like come up with improvements. Yeah. In the US, the failure has basically been that when that goes well, it's like, oh, thanks so much, here's a little bonus. But then when there's a downturn, you get fired. That person no longer really cares to help you with your business. Like there's a lot of loyalty lost. I
wonder, because like the immediate equivalent that I think of is like in the US, there's a lot of like unionized areas or government jobs where you're like, I don't know if it's explicit, but you're de facto have a job for life. And there's not the same kind of buy-in or improvement in many of those organizations.
Yeah. Yeah. It's a very different relationship with the union in a number of ways. But I think my point is that in terms of chasing things down to the end, basically, like, a lot of shops would say, well, we can't guarantee work for life because we don't know, or we can't guarantee that we're not going to fire people during a downturn because we can't predict a downturn or whatever. But I think the counter argument is sort of not necessarily on the labor front, on any front. I think the difference in approach is you can absolutely plan for these things if you treat them as, okay, well, why would it be an issue if we have a downturn and we don't want to lay people off? Oh, it's a cash flow issue. Okay, how much cash would we have to keep on hand? Or how many projects would we need to sort of have in the pipe that we are very bullish on, right? Like big improvement projects, or like, oh, we want to totally rearrange the plant. Let's queue those things up and then tackle them in a downturn and have the cash planned for and have like all these things.
Make it a priority instead of just sort of being reactive to the market.
Yeah. And I think asking why 5 times is super key, because there aren't many things that are actually out of our control, and the ones that are completely out of our control, like, we can think through the effects they'll have on us and plan for those.
Yeah. So you're saying we need to hire more people and then have them work on production or work on improvements when we don't have enough work?
Not really. I mean, for me, like, even adding Sam to the team, that was part of it. I was like, okay, well, I'll just have him work on improvements that I want to tackle when there's not enough work.
And there hasn't, like, for the most part, this has been my experience as well. He's just working.
Yeah, slightly less than he wants to be. Like, we started part-time, and then he was like, okay, can we do full-time? And I was like, let's hang off. So now we're up to 4 days a week instead of 5. And I think coming into the summer, we'll probably make that switch. Yeah. But it's just like hard, as I mentioned, on a business to double the available man hours, basically. Yeah. Like, there's just a lot of stuff that sort of needs to start shifting, like the velocity of sales.
The whole pace has to come up.
Yeah. And it is, but not overnight.
Yeah.
So that was our fun day of production. Just a series of failures, all ending up in a day that felt extremely disorganized. Like you were sort of saying last week, I had the like, oh my God, that like everything's on fire. Then I kind of looked around and I was like, we're still crushing it, like relative to where we were, right? Yeah. So that was also cool to see.
That's good. Yeah, it's important to remember that.
It's fine. Yeah.
And just to have that thinking back at 6 months, a year perspective, and be like, we're actually doing really good today. Not to like pat ourselves on the back, but just to not be, it's so easy to get down on yourself completely. Yeah. And just feel like you're just not succeeding in your job on a day like that.
Yeah. I feel like it can get pretty, not maybe overwhelming is an overstatement, but just my focus is almost by definition the things that aren't working. Right. And so I'm meditating on those like all day, every day. And that can get, Yeah,
totally.
It's a very specific perspective.
Yeah. It's a very small thing. We had mentioned a while back the potential that Brother Machines don't need an M5 before a G100 for the machinist geeks out there, which is a spindle stop before a tool change. And our friend Matt Blackwell, Matt, tested it yesterday. And it does in fact work and saves, what did he say? I'm going to have to do a little math. He said it saved 7 seconds over 9 tool changes.
So a little under
0.77 seconds per.
Yeah.
Which doesn't sound like a lot, but for a machine that takes 1.3 seconds chip to chip, that's a significant portion of the time.
That sounds like a post-edit begging to happen.
Exactly. Yeah.
And so that means that it's built into the tool change.
It's built into the G100 line because you can also tool change a brother
Not
without
T6.
it. Not a
M6.
Yeah.
M6 does not have it built in.
Does not have the spindles. Well, I don't know. It might just alarm. I've never tried it.
Interesting.
While running with.
Seems like a dumb thing to alarm because they could just build it in the ladder.
Well, that's Anyway,
but
not going to try and get behind the brother's head, but the G100 does it all.
I didn't realize that was in all of the code. Spindle stop before.
In the Fusion / the Autodesk posts, I'm fairly sure it's in everything. It is in everything I've used.
Okay, I'm gonna look for it because I run the same program all day every day, so that would be an easy couple seconds to take off of each one.
Yeah, probably more. I don't know, how many tool changes do you do per part?
Yeah, probably more.
Yeah.
Trying to think. I'll count them up.
Assuming it was the same.
Yeah, 0.7.
7 seconds times, you do 30-ish parts in a...
I do, let's say 30 on average. And let's say I don't know.
That's 3.5 minutes per load.
That's awesome.
Yeah. Thanks, Matt.
Yeah. Send you a check. It'll be a small check. Yeah. So I thought, so I was sort of talking through automation and thinking about automation and just wanted to mention some stuff that I found very interesting. Basically, Toyota divides automation into 3 stages: pre-automation, automation, and automation. I may get this slightly wrong, but the idea is basically that automation is like automating your reloading of the machine, so it can keep running on its own, right? And you're unloading, right? So it can keep running on its own. It can't detect when things are not operating correctly, and so that's what they call automation. That's what they call pre-automation. Is when a machine will just keep running. It can be making garbage. It can be making good parts. It doesn't know. Automation. That's pre-automation. Automation is where it can detect when things are out of the norm and stop itself. And then automation is where it can then correct those that error and keep running. Yeah. I forget the exact number, but it's something like 80% of your results. I mean, classic Pareto, like 80% of your results come at 20% of the cost to get to automation, and automation is extremely expensive and very hard. And so a lot of what Toyota aims for is automation where it can detect abnormalities and stop, so you're not making defects, and then you count on humans to come correct the operating conditions back to normal. And I think that's really interesting in that I think a lot of people who are running pre-automation think they're running automation, and that includes myself, right? Where like when I got to the machine and it had run 30 parts that were absolute trash, that is pre-automation, right? It kept moving. And that's not to say I don't have checks in there, but I wasn't checking for that out of normal condition. And there's huge value in that. I was sort of thinking about trying to estimate our total. It's easy to look at failures as abnormal instead of to say, okay, if we we run 30 days with no issues and then we run, or 29 days with no issues and then we run one day where we have downtime of half a day, we could divide up that downtime over those 29 days and say, let's give ourselves an extra 3 or 5 seconds per part to make sure we don't have that condition and we're still going to be ahead. Right. And I think it's easy to get focused on cycle time, like probing takes time. This validation stuff takes time, and it's easy in my cost of goods chart to say, oh, it's this long cycle. Sure. So I'm going to bump it up. Anyway.
Yeah, that kind of comes back to the goal and like not having your cost of goods and your theoretical costs be your driving forces. Yeah. And looking at your total throughput, throughput, whole picture, and really letting that drive your decisions.
Totally. So
Yeah.
For those trying to automate, approach it in those steps, because pre-automation is worthwhile.
Yeah.
But not that worthwhile. And then automation is also worthwhile, but
very expensive.
Very expensive.
And maybe out of reach for most.
I don't think it makes sense for me.
Yeah. And maybe out of reach to the point where it stops being cost effective.
Yeah. Now, there are different options, right? Like automation, you can also treat as sister tooling, where when one tool detects broken, you can try running with the other tool.
There's not like a clear delineation between these three.
And it's not all or nothing. Yeah. It's like I detect broken tools currently, so that would be automation, but I don't detect whether a part has been dropped into the finished bin.
Right.
So.
Yeah. Anyway. Or if that part that got dropped in was good.
Yeah. Yeah, and in thinking about taking those measurements, I don't know. I don't know that I can afford to do it every single time. Maybe I do it every 10th time. Maybe I do, right? Like I could stop and probe a bunch of stuff on the part before I unload it from the vise, but I don't.
Yeah.
Currently.
Well, also I think like it's not probably your key issue right now. It's like something I'm sure it's something you'll approach at some point when like everything else is just running peachy and you're like, okay, we need to deal with this, small problem comparatively.
Absolutely.
Yeah.
Now for overnight runs, it starts to become a little more tempting to put that time in.
I guess like, you mean just because you're making more parts, but without being able to check in person?
If it's $400 or $500 of stock,
that
I'm gonna make into trash,
sure,
in a night.
Yeah, I guess I'm just trying to put on a different perspective for a second. I don't like. I think we focus on overnight versus daytime run a lot, but I think
it's just the interval. Like I come to the machine every 40 parts.
Right.
If suddenly we're bumping that up to 400 parts, the risks increase in just the
number of things that can
the number of bad
wrong.
Parts I make. I think anyway.
Yeah. Although, like, are you aside from something massive? I'm just like,
I'm not worried about a crash.
No. I'm just playing devil's advocate here for a second. Aside from something massive like parts cut in half, like you're not necessarily going to find small defects during the day anyway, right?
During the day?
Yeah.
Oh, during the day we do. We do an inspection.
And do you inspect everything?
No. Oh, small defects that are sort of like 1 in 40? No.
Yeah, or like, I guess what I'm trying to say is I think we often let ourselves off the hook for daytime running because we're just like, we'll just catch that.
Yeah.
And I think in reality, like most of the difference between daytime and nighttime is runtime, but we don't necessarily actually catch those things during the day. We think we would.
That's a good point. I see what you're saying because we do a full 100% inspection after paint.
Yeah.
Which, if we don't produce more than we typically, like if there's not more in our pipeline before that 100% inspection from an overnight run than a day run, then maybe we do need to detect big issues like the wrong vice jaws being put in. Yeah. But maybe the small issues are not worth worrying about.
I guess that's what I'm saying is like, for a lot of this, like more unattended running, it's more about the big safety things like cracked jaws, not broken tools.
Right.
And like part measuring is great, but maybe not actually the critical.
That's a good point. Especially if you look at the cost and versus benefits of overnight runs. Like, yes, there's going to be some crushing mornings where you get in and you're like, wow, that's hundreds of dollars, but it's easy to forget that you ran for the previous, 10 nights. And that is a huge bump in revenue and capacity without having to buy a second CNC.
Yeah.
So, yeah.
Yeah. Well, I think that is our episode for today. Thank you all for listening.
Absolutely. You can find me at austere_manufacturing on Instagram.
You can find me at lichen_MFG on Instagram.
And then the podcast is Incremental CI, also on Instagram. Love hearing from you guys. All feedback is good feedback. And we'll
see you later in the week.